On a rogue planet, the radiation doesn't come from one direction, it comes from all of them. Close your eyes. Imagine absolute dark. Not the dark of a power outage, not movie darkness with ambient glow from the edges. Nothing. No shape. No hand in front of your face. No horizon. The planet beneath your feet is real. You can feel it. You cannot see it. And you are already dying. Not from the cold, from something you will never see, never feel, and cannot shield yourself from by turning away. Every direction is the source. Your instinct says move, get behind something, find a wall. That is the correct instinct on Earth. It fails for a reason the instinct cannot account for. The threat is not in front of you. It is not above you. It is not below you in some abstract sense. It is literally arriving from the entire sphere of space simultaneously. The floor you are standing on is receiving it from beneath. The air above your head is receiving it from above. The rock to your left and the emptiness to your right are both delivering it from their direction. You cannot rotate to face it. You cannot crouch behind terrain. The terrain is already irradiated. The moment you stood on this surface, you were already inside the source. This is the physics that lives behind the idea of a rogue planet. A rogue planet is a world without a star. It was ejected. It was thrown out. During the formation of a solar system, planets that form too close to large neighbors can get flung outward with enough velocity to escape the system entirely. This happens during routine solar system construction. It is not a catastrophe edge case. It is a standard outcome. Some models suggest that for every planet that ends up in a stable orbit around a star, another was discarded into the dark. They drift at tens of kilometers every second in no particular direction with no destination. The galaxy is full of them. In 2011, astronomers analyzing data from a wide-field infrared survey telescope identified at least 10 Jupiter-mass objects moving through the Milky Way with no gravitational attachment to any star. The research team, led by scientists at Osaka University, published a population estimate that forced a significant revision to planetary formation models. These were not anomalies. The data implied that free-floating planets outnumber stars in the Milky Way by at least 2 to 1. More planets exist outside stellar systems than within them. The most common type of planet in the galaxy is not orbiting anything. It is alone in the dark, exposed, drifting, and has been for billions of years. That is not a romantic image. It is a death sentence measured in geology. The sun is not just a heat source. It is a magnetic shield. The sun constantly pushes a wind of charged particles outward in all directions. That wind fills a bubble hundreds of times wider than Earth's orbit. Everything inside that bubble, every planet, every moon, every rock in the asteroid belt, sits behind a deflector. High-energy particles originating from violent events elsewhere in the galaxy, exploding stars, colliding neutron stars, accelerating regions of interstellar magnetic turbulence, constantly bombard that bubble from outside. The bubble turns most of them away. Roughly 3 out of 4 never reach the inner solar system at all. Earth receives only the quarter that got through. A rogue planet receives all of it. No bubble, no solar wind, no deflection. The full flux of galactic radiation, unfiltered, from every point on the celestial sphere arrives at the planet's surface at full intensity. The dose rate at the surface is not slightly higher than Earth's. It is not twice Earth's. It is approximately 4 times Earth's baseline, before the planet's own missing magnetic field is accounted for. Earth's magnetic field provides a second layer of protection on top of the solar wind. It channels charged particles toward the poles and deflects the rest. A rogue planet ejected from a system billions of years ago has had those billions of years to cool. Its core may have solidified. A solidified core generates no magnetic field. Both shields are gone. The radiation arrives, all of it, from everywhere. On your skin, this is invisible. You feel nothing. The particles are not heat, they are not light. They pass through your clothes, through your skin, through the water in your cells, through bone, and continue downward into the rock. They do not stop at the surface. They penetrate meters down. Some of the highest energy particles, carrying more energy per particle than a baseball pitch compressed into a single atomic nucleus, pass through the entire planet and emerge from the other side. Your body intercepts a fraction of that flux. That fraction rewrites the instruction codes in your cells. The cells that can repair themselves do. The ones that cannot accumulate damage. After enough accumulated damage, the tissue fails to function. The failure is not immediate. It begins the moment you arrive. Day 1 looks fine. Day 3, the nausea begins. By day 10, your body is cataloging damage faster than it can repair it. To put the numbers into the only frame that matters, on Earth, a person standing at sea level receives roughly 1/3 of a millisievert of cosmic radiation per year. It is low enough to be nearly irrelevant to your health over a normal lifetime. On the surface of a rogue planet with no stellar or magnetic shielding, estimates place the dose rate at hundreds to thousands of that amount. Not per year, per day. Lethal accumulated exposure arrives in days to weeks. Not months, not years. Days. The surface of a rogue planet does not kill slowly. It processes biological matter. There is no angle to stand at that reduces this. The most obvious engineering response to radiation is shielding. You build a wall between you and the source. It works because the source has a direction. You know where the radiation is coming from, and you put mass between yourself and it. A thick enough lead wall stops most things. A thick enough concrete wall stops most things. The physics of directional shielding is well understood. It has protected workers in nuclear facilities for decades. It has protected spacecraft in ways that matter. The logic is sound. The problem is that it depends on the source being somewhere specific. Build a shielded habitat on the surface of a rogue planet, and you face a geometry that defeats the logic entirely. You shield the roof. The radiation from above decreases. The radiation from below does not change. It still comes up through the floor, through your feet, through the chair you were sitting in, through the wall you were leaning against. So you shield the floor too, and the walls. All of them, on every side, simultaneously. You need a closed shell with meaningful radiation mass on all 6 sides. Meaningful mass means meters of lead, or tens of meters of water, or hundreds of meters of compacted rock. The moment your structure is less than that on any one side, that side is delivering a lethal dose rate with nothing between it and you. The math of building a fully enclosed, complete sphere radiation shell above ground runs directly into structural physics. That much mass cannot hold itself up on a planetary surface without ceasing to be a habitat and becoming a geological formation. You are, in engineering terms, trying to build a cave out of fabricated materials at enormous energy cost to replicate what the planet's own rock already does for free, underground. The planet solves the problem, at the cost of everything else. Go underground and the rock does the shielding from all directions simultaneously. 1 kilometer of rock overhead stops almost everything. 2 kilometers stops the rest. The dose rate in a deep subsurface cavity on a rogue planet may be comparable to Earth's surface dose, or possibly lower. The physics of the shielding is genuinely favorable. The rock is there. It is dense. It surrounds you from all sides by default. No construction required. You are also now sealed inside a planet with no exit. The surface above you is permanently fatal to biology at any time scale beyond hours. You cannot go up there to check equipment. You cannot go up there to receive a rescue signal. You cannot go up there at all. Your habitat is a cave system. It has no windows by definition. No natural light enters, and no useful light exists at any depth to observe. Every resource your colony needs, energy, heat, water, air, minerals, must exist in the subsurface and be extracted there. The geothermal heat from the planet's formation may still be present. Large rogue planets retain internal heat for billions of years. Geothermal energy is physically available, but it is entirely dependent on the continued geological activity of a planet whose internal state you cannot monitor from the surface, whose thermal output you cannot predict decades in advance, and whose cooling rate you have no reference point for. The colony may have millions of years of warmth remaining. It may have decades. You have no instrument that tells you which. If the geothermal source cools faster than expected, the heat goes first. Then the liquid water in the subsurface, if any exists, begins to freeze. Then the structural integrity of the cave system changes as thermal contraction alters the rock. The habitat that was geologically stable becomes a pressurized container inside a rock that is contracting around it. None of this happens with a warning light. The indicators are geological, meaning they arrive in timescales of decades rather than hours. And the difference between the planet is fine and the planet is cooling faster than expected may only become visible when the temperature drop is already irreversible. You cannot go to the surface to look for another option. There is no surface to go to. A team of researchers working with data from a microlensing survey published their findings in 2011 with clinical precision. The telescope had measured the slight bending of starlight caused by the gravitational pull of objects passing between the telescope and distant stars. Most of those passing objects were stars or bound planets, but 10 of them were planetary mass objects with no detectable stellar companion. The bending was brief. The objects moved on. The team did not claim dramatic conclusions. They published a ratio. The number implied that for every star in the Milky Way, roughly 2 unbound planetary mass objects are moving through interstellar space. The discovery was not a prediction or a model output. It was an observation of light that had been slightly bent by worlds already in the dark. Those worlds were already irradiated before the measurement began. The surveys that followed and the modeling that responded to this discovery established something that changes the frame for thinking about planetary habitability. A planet is not inherently hospitable or hostile. A planet within a stellar system is partly protected by architecture it did not build. The star's magnetic wind enwraps the entire system. The planet's own field handles the residual. Strip the star away, and none of the surface-level properties of the planet, its size, its geology, its chemistry, its water content, determine whether biology survives at the surface. The radiation flux determines it. And the radiation flux on an unshielded world has only one answer. Habitability is not a property of a planet. It is a property of a planet inside its star's protection. A rogue planet can have a subsurface ocean. Some of them almost certainly do. The models show that a planet large enough retains internal heat long enough to keep liquid water beneath an ice shell 10 to 100 kilometers thick. There may be more liquid water on rogue planets scattered across the galaxy than in every ocean of every solar system combined. The water exists. The chemistry for biology may exist. The pressure at depth permits it. The temperature permits it. Everything that makes a subsurface ocean interesting is present. None of that water has ever seen radiation. It is buried under 100 kilometers of ice that the surface is trying to irradiate from above. The Roman Space Telescope, currently designed to carry out a microlensing survey with sensitivity far beyond the 2011 instruments, will produce a population estimate for free-floating planets that will be precise enough to categorize them by mass and distribution across the galaxy. It will identify thousands of them. It will produce a map in rough statistical terms of where they cluster, how fast they move, and how many exist in each mass range. It will count them accurately. It will not change the surface dose rate on a single one.